Hello everyone, I'm Stanley from Matanda.
My name is Harvey Zayed.
We are finalists from Germinating International School, Matanda, Mozambique, and our project is about the protective antioxidant effects of sulforaphane on germinating radish seeds treated with hydrogen peroxide. Free radical chain reactions result in atoms containing unpaired electrons binding biomolecules and alter their biological functions, contributing to the progression of diseases such as atherosclerosis, cancer, and diabetes. Antioxidants such as vitamin E and sulforaphane are effective neutralizers of free radicals and prevent cellular damage. This present study is conducted to determine the relative effectiveness of sulforaphane against free radicals germinated by hydrogen peroxide or H2O2 compared to the non-antioxidant vitamin E. In this experiment, H2O2 is a source of free radicals and germinating radish seeds are modeled to test the protective antioxidant effects of free radicals.
Free radicals are atoms or molecules that are hazardous to cell health and are cause of many genetic diseases. Free radicals have an unpaired electron with their outer shell that makes them highly reactive. Because of the removal of this electron, the biomolecules become unstable. As a result, this instability results in a cascade in their chain of electrons, making them biologically unstable, causing cell degeneration or death. Some sources of free radicals in our system come from burnt or smoked food, alcohol, ionized radiation, radioactive substances, and many others coming from machine exhaust. As a result, this can cause many degenerative diseases such as atherosclerosis, diabetes, cancer, asthma, degenerative eye disease, yes, and aging genetic material within the cells.
Yes.
Thus, many living organisms have evolved with certain molecules or enzymes systems that largely counteract damage from arising from free radicals. Nevertheless, naturally occurring compounds in our diet are called antioxidants. Antioxidants play a very important role in neutralizing the free radicals. Yes, by donating an electron through an ionic bond or by activating the enzymes that can neutralize the free radical reaction, thereby protecting their biological molecules. Antioxidants also vary in their neutralizing properties to counteract the free radicals. Vitamin E is also well known as an effective antioxidant against free radical scavenging antioxidant in vivo that forms 8 tocopheroxyl radicals as the intermediate in its radical scavenging reaction. Recent studies also demonstrate that phytochemical ingredient of sulforaphane can be found in many cruciferous vegetables such as cabbages, sprouts, Brussels, and broccoli that can be cytoprotective as an act of the antioxidant molecule acting through the activation of various antioxidant enzymes in response to antioxidant stress. However, this relative effectiveness of various antioxidant molecules is still not known.
The solutions for each of the experimental groups were prepared using a graduated cylinder. For this experiment, there were 6 petri dishes with 10 radish seeds in each that a different 10 ml treatment added to each one, as seen in figure 1. First, coffee filter discs were placed in each petri dish at the bottom to produce a foundation for seed germination to occur. 10 ml of distilled water was added to the control group and 10 ml of 1% H2O2 diluted from 3% H2O2 was added to the comparative control group. Next, the contents of a broccoli extract rich with sulforaphane was added to the contents of a broccoli extract rich with sulforaphane peel were added to 10 ml of water, still well filtered, and added to their respective petri dish labeled as sulforaphane. This step was repeated for the vitamin E peel, and the solution was added to the vitamin E petri dish. The concentration of the sulforaphane related treatment was 400 mcg per 10 ml of its corresponding solution and is comparable to the 400 IU or 20,000 mcg per 10 ml of its corresponding solution, as both are the recommended daily dose as established by dietary guidelines.
After 3 days of incubating radish seeds in the presence of 1% of hydrogen peroxide with or without antioxidant, the seed germination rates are recorded and analyzed. A representative picture of the germinating radish seeds with different treatments shown in figure 1 and table 1 displays the summary of the radish seeds germination results obtained by 4 different individual experiments. In all, the experiment derived from significant results based on one-way ANOVA test that were equal to p less than 0.05.
In conclusion, this study was designed to determine the relative effectiveness of sulforaphane in preventing the effects of free radical on germinating radish seeds. Our experimental results support that sulforaphane is more effective in neutralizing free radicals compared to the antioxidant vitamin E. The results on the present slide show that sulforaphane-rich broccoli extract can act as an effective antioxidant and suggest that this extract is more potent than vitamin E. In fact, this study is helpful to further expand on existing research regarding sulforaphane and its potential effects and uses as an endogenous antioxidant. Thank you for the attention. Dismissed.